There are a few things that I want you to be very cautious of. One, you need to be as accurate as possible, which means you need to use a ruler and you need to draw straight lines. I found that as people were asking me questions, if you draw in big points, that's where your lines become inaccurate a little bit. So you can line up your ruler, and now mine's going to be different than yours because I just drew it in. You can line up your ruler and that point of the F and draw in your line. You don't necessarily need a big point there. Okay? You can, but you don't necessarily need it. Now, when you're measuring, also be as accurate as possible. So when I look at mine, and again, yours is different. Mine is at 1 after the halfway mark. So when I move this down, 1 after the halfway, here is my point. Yours is going to be a little lower because yours was closer to 1. Okay? Do you notice the difference between my tiny mark and the actual point?
Yes.
Yeah. Some of you were putting a lot of points on your paper and then you were confused about what points to connect. Okay, so this mark here should literally just be a mark so you know where to place your ruler. This should be the actual point. Now when you're drawing things in, you're obviously doing the whole thing. I'm going to cheat real quick. I know. You'll survive. Okay, so you have these points, and then you have a point here, right? Again, yours looks different. I just fake drew mine in. You have a point here. When you are drawing in this point, because I told you you didn't have to find this one, you could just create a horizontal line. You need to make sure it's horizontal. Now, this is going to be wrong. But that's obviously not what it's going to look like. Yeah, well, as I walked around, some people had that. So, make sure that you line that point up with the vertical line and it is as straight as possible. If it's slightly off, that's pretty good. If it's slightly off, I'm not going to mark off points. However, if it's all janky, I will. So, if for whatever reason I gave you the letter K tomorrow, but that's not the letter, let's pretend. You have 1, 2, 3, 4, potentially 5 points because you need to know where it crosses. Okay, so just know that it's not going to be a block letter. It's a single, like, stick figure letter. Questions on enlarging a letter. It will still be a scale factor of 3 because that's what we've been doing for the last few weeks. You'll have a ruler. You just need to make sure it's accurate. Okay? Questions there? All right, let's look at the actual practice. So, as always, your test will be on Edulastic. I am going to give you another kind of practice test today for when we finish / for homework. Some people finished in class. And it will just give you the option of being able to graph online because some of these you had to graph. And it'll show you how to do that. Once you submit today's assignment, you'll be able to see which questions you got wrong and why, so you know how to fix those issues for tomorrow. Okay? So first things first, use the graph below to find the scale factor of the image to the pre-image. How do I find scale factor to begin with? Ignore in general. How do I find scale factor? You can look at points. You compare side lengths, but I need to create what? A proportion or a ratio, right? And you said compare ratios, but I want more specific. What do I need to compare? What to what? Other way around. Image to pre-image. So your new to your old. Okay, image over pre-image. Which one of these is my image and which one's my pre-image? The bigger one's my pre-image, the new one's my image. How did you know that?
Because the smaller one has its points in your corner.
Okay, the smaller one has the points and then the primes next to it. Okay, there are two ways you can find scale factor on a graph. One, you can look at the side lengths. Two, you can look at the coordinates. So let's start with side lengths. What two side lengths could I compare? CB and C prime B prime, right? So what's CB? What's the side length of CB? 9. What's the side length of C prime B prime? 3. Okay, so image over pre-image gives me 1/3. How come we didn't choose AB and A prime B prime?
Because since they're like slanted, it's harder to
So because they're slanted, you have to do more work. How would you find the distance of AB or A prime B prime?
distance formula.
The distance formula. And all of you love the distance formula so much from the beginning of the semester, you're going to use those side lengths. No? But you could, right? If I asked you to find the side lengths, you could do it. You know how to?
Yes.
Okay, good. But let's make it easy on ourselves, and if we can just count boxes, let's go with that. The second way to do it is to look at the ordered pairs. So pick a point. A. Great. What's the point A? What's the ordered pair for A?
9 and 3.
9, 3. I also then need to look at A prime. What's the ordered pair for A prime?
3, 1.
3, 1. Okay? You have to look at the same point, so A and A prime, B and B prime, and so on. And then you're either going to compare the X values or the Y values. So let's start with X's. Again, it's image over pre-image. So 3 over 9 reduces to 1 over 3. That's the X values. If I compare the Y values, I'm going to get the same answer. And I can do the same thing with B and B prime and C and C prime. Okay, so no on your test, you could either count side lengths in some cases. Technically, you can use the distance formula, or you can use ordered pairs. I will tell you, though, on your test, you may see an ordered pair that looks like this. Ellie can confirm because she is currently taking your test.
I'm doing really good too.
So, if I'm going to find the scale factor of this A and A prime, what 2 points would I need to look at?
The Y.
The Y's. So I would look at the Y value. So that would be 2 over 4, which is 1/2. Why would I not use the X values?
Because they're the same thing.
Because it's 0, right? If you multiply 0 by a scale factor, your answer is still 0. So my hint and note to you for tomorrow is if you see 0 as a point, you're not using it. Okay? Pick a different point that has a number other than 0. Does that make sense?
Yep.
Okay. Number 2, apply the scale factor to the pre-image and name the coordinates of both figures. So first of all, I need to know what the coordinates of the pre-image are. So B is -3, 1. C is 0, -4. And U is -3, -3. Okay, so those are the coordinates of your pre-image. I'm going to apply the scale factor of 0.5 to each of those points, giving me -3/2, -1/2. If you wrote it as a decimal and you did -1.5 and -0.5, that's fine. Okay, so I'll take either a fraction or a decimal. C prime is 0, -2, and U prime is -3/2, -3/2. So those are the coordinates of your image. Yes?
I put it as a decimal
That's fine. So I will take a fraction or a decimal.
on the test too.
Yep.
Okay.
Fraction or a decimal on test. Yes, sir.
Is there a mixed number on it?
No. So it needs to be an improper fraction or a decimal. Before I graph, when I look at my scale factor, what type of dilation occurred?
It's got small.
It's a reduction. So you're going to be asked what type of dilation happens. In this case, it's a reduction. Which means when I graph, because it tells me to graph the image. It should be a triangle that looks exactly the same, just smaller, right? So I have negative 1.5, negative 0.5, so here's B prime. 0, negative 2 is C prime. And here's U prime. So it's the exact same triangle, just a whole lot smaller. Questions there?
So when we take the test tomorrow, we're going to be graphing.
The test tomorrow you will graph, yep. And you're going to practice that once we're done here. Graphing on the computer is actually pretty easy for this unit. Okay, it's just a matter of like moving points.
I remember Houston taught us.
Yeah.
Yes.
All right. Number 3. So my pre-image points are negative 1, negative 1, negative 2, 2, 3, 1, and 2, negative 1. And if I apply a scale factor of 1.5, what's going to happen? It's going to get bigger, so it's an enlargement. All right, when I apply 1.5, I get negative 1.5, negative 1.5, then negative 3, 3, 4.5, 1.5, and 3, negative 1.5. So you multiply each of those coordinates by 1.5. When I go to graph, here's G prime, N prime, T prime, Z prime. Is it the same trapezoid, just a whole lot larger?
Yes.
Well, not a whole lot, but larger. Okay, that's what should happen. All right, questions there? Number 4, you're solving a proportion, so cross multiply. So 4a equals 35. If you divide by 4, 4 and 35 don't reduce, so I will take 35 over 4, or I will take 8.8. So you can make it a decimal, make sure you round it to the nearest tenth. Okay, I will take either answer. Number 5, 3x equals 36. Divide by 3, you get x equals 12. Number 6, when I cross multiply, I get 60 equals 4 times n minus 2. You need to make sure that you distribute the 4 to both terms. So 60 equals 4n minus 8. If you add 8 to both sides, 68 equals 4n. And when you divide by 4, n equals 17. Still doing okay? Okay. Hopefully the proportions are a whole lot easier now. It's just making sure you add, subtract, multiply, and divide correctly. A lot of this test is multiple choice. So if your answer's not there, you did it wrong, and you should go back and do it again. Right? If it's a multiple choice test. Okay. When I cross multiply here, I get 36 equals 2n plus 9. Oh, 18. Does everyone see what I did?
Yeah.
So I skipped this step. Are you okay with that?
Yeah.
Yeah? Okay. If I subtract 18, 18 equals 2n. Divide by 2, n equals 9. Number 8. 2x equals 8x minus 72. When I subtract 8x from both sides, I get negative 6x equals negative 72. Divide by negative 6, you get x equals positive 12. And then lastly, number 9, 6p equals 2p plus 2. If you subtract 2p, you get 4p equals 2. And when you divide by 4, I will accept 1/2 or 0.5. Okay, so if you leave it as a fraction, you need to make sure you reduce that fraction. So 1/2 or 0.5. Questions on anything on the front? We're good? Okay, let's look at the back. Number 10, the figures below are similar. Find the scale factor. So again, it's image over pre-image. Which one's my image?
The larger.
The larger one, it tells you. Which means the small one's my pre-image. And because they're already similar, we're comparing either of the two sides. Which sides would you like to compare? GH and CD, okay, which is going to be the same as BA because it's a rectangle. So 15 over 6 reduces to 5 over 2. If you did 25 over 10, it also reduces to 5 over 2. Okay, you can also again compare 25 over 10, which gives you 5 over 2. All right, number 11, find the scale factor and then solve for the variable. So first of all, let's find the scale factor. Which one's my image? The smaller one because of the primes. Here's my pre-image. And what two sides can I compare? AC and A prime, C prime, right? So 2 over 4 gives you a scale factor of 1/2. I'm going to show you two ways to solve this. So the first thing is you take your scale factor and you create a proportion with the other side lengths. So I have x and 9. And then you can solve that proportion. If you cross multiply, you get 2x equals 9 or x equals 4.5 or 9/2 if you kept it as 9/2. Or if you know the trick, all you're doing is you're multiplying 9 by your scale factor to get your variable. Okay, so you can either set up a proportion and solve if that makes more sense, or you take your side length, multiply it by the scale factor to get your variable. Questions there? Did we get 4.5? How many people just multiplied? So the 5 people, okay. And everyone else used proportions, or we just guessed? Used proportions? Okay. So either one's fine. Number 12 and 13, we need to determine if these figures are similar. How do you determine if figures are similar? Compare all the side lengths, because all of them have to be the same. So yes, you're looking at scale factor, but you have to make sure you look at every single side length. So what should I start with? 18 and 63. Okay, if you did 63 over 18, that's okay. You're just going to have a completely opposite fraction from what I have. And we'll talk about that more in a second. If I reduce 18 over 63, I get 2 over 7. So let's compare 12 over 42, giving me 2 over 7. And lastly, 10 over 35, giving me 2 over 7. So in this problem, it doesn't tell me to go left to right. It doesn't tell me to go small to big. I went left to right. If you went right to left or you did it in a different direction, you're going to have completely opposite of what I have. So I have 2 over 7. You'd have 7 over 2. That's okay. Unless it tells you specifically which direction to go, whatever direction you choose is fine. Okay? So these ones are similar because the scale factor for all of them is the same. Number 13, let's compare the heights first. So 60 over 48 reduces to 5 over 4. And then what'd you compare here? 80 over what? Why'd you do 56 instead of 28?
Because that's the radius, not the diameter.
Okay, so you either have to compare the diameter in both or the radius in both. I'm going to do the radius just because it's already going to be a little more simplified, but you're going to get the same answer. So I'm doing 40 over 28. If you do the diameter, it's 80 over 56, but that reduces to 10 over 7 in either case. These are not the same, which means these two cylinders are not similar. Okay? Are we okay with that? Awesome. So far, so good on this. I'm hoping for a really good test score tomorrow. No, you're not. Okay, last one. We need to find the scale factor. Where should I start? Okay, let's take our volumes and make it a ratio. So I have my volumes and I have it as a ratio. I need to simplify that ratio. You can do it by hand or you can use the ABC button in your calculator. For those of you that have the TIs, you need to remember that if the numerator is larger than the denominator, it's going to give it back to you as a mixed number. So it gives it back to you as 5 and 23 over 64. If you know how to convert that, you're good. If you don't, you need to start dividing, okay, and simplify that by hand. So here's multiplication and then addition. So 64 times 5 plus 23 gives you 343 over 64. What is this ratio called? Ratio of volumes. You took your volumes and you simplified a ratio. I want scale factor, so I'm going from something large to something smaller. How do I find the scale factor?
You find the cube.
You take the cube root. If you have a Casio calculator, you have the cube root button on your calculator. If you have the TI, that's where you type in 3 and then the button that's the X and square root, because that's the cube root of, and then you would type in 343, and you end up with 7 over 4.
So if we get a problem like that, do we just put 7 over 4? Or is it going to ask us for both ratio and volume?
I think it specifically asks you. So if it asks you for scale factor, this would be your final answer. If it asks you for like the first step and then that step, you'll have to type in both. So just make sure you read the directions on that. Okay. Now, real quick, because this wasn't on the practice test, what if I found the scale factor and I wanted the ratio of volumes? So this is my scale factor and I want ratio of volumes. How do I find that?
You cube it.
You cube it. So 2/7 cubed would give me 8 over 343. So make sure you know how to go both ways. So if you're going from scale factor to ratio of volumes, you cube it. If you're going from a ratio of volumes to scale factor, you take the cube root. Okay? Questions, comments, concerns? Yes? Like from this to this?
Yeah.
So you have two options. You can do it by hand, or you have that ABC button on your calculator. So 7,546, and then you type in ABC, and it gives you like a little, I don't know what that would be, like a half of a box. And then over 1408. So this is what it's going to look like in your calculator. Remember, that's 2 and 23 over 64, so it's a mixed number. And that's where you have to convert the mixed number to an improper fraction. Or you just start dividing by hand. I know 2 goes into both of those, so I simplify by 2. And you just keep going. Any other questions? Does that answer your question, Izzy? Yeah? Anything else?